In this video, we are going to study about the mean value theorem. So the objective is describe the statement and the conditions of mean value theorem, determine the existence of at least one point on the closed interval where the instantaneous rate of change equals to the average rate of change over an interval, or in other words, slope of tangent line equals to the slope of secant line. Now, when we say slope of tangent line, so you must know that if we have a curve, for example, this is the curve, and if the line touches the curve, okay, at least at one point, then this is said to be a tangent line. This is said to be a tangent line, the line that touches the curve only at one point. But if we take the 2 points on the curve and we make a line, okay, so this is said to be the secant line because it is made by connecting the 2 points on the curve. Similarly, when we say that the instantaneous rate of change, it means that the derivative of the function. Whereas when we say the average rate of change, it means the rise over run. That means the slope of a secant line. Let's try to understand about the mean value theorem. So the mean value theorem, first of all, it is very necessary before applying the mean value theorem that the function must fulfill the two conditions. So the first condition, same as the Rolle's theorem, that the function should be continuous on the closed interval a and b. So if we have the initial point a and the final point is b, then the function should be continuous in the closed interval. In the closed interval means that the a initial point is included and the final point b is included. So it is very necessary that the function is continuous from the beginning till the end of the point, and there should not be any kind of discontinuity. And what is meant by discontinuity? That the graph must not have any kind of hole. The graph must not have the broken lines, or the graph must not have any kind of the broken line because of the vertical asymptote. So each and every point are included in the graph from A to B. So let's suppose if we have a graph like here, okay, and over here there is a hole, okay, but you have to read the graph from here till here, okay. So you only have to look at these points only, the A point till B point. So from A till B there is no discontinuity. So because this is not coming in our interval, so we just ignore this even discontinuity. That's why we have to write that it has to be continuous on the closed interval and make sure that the A point and the B point are included. Okay, so the second point states that the function should be differentiable in the open interval. Now, differentiable in the open interval, why we say so? That we have to study between A to B because we don't want to make any kind of the slope at the edges of the function. Okay, that's why we say they should be differentiable in the open interval. And when we say that the differentiable, it means that there should be a smooth curve. Okay, as you can see in figure 1 and 2, there should be a smooth curve. Okay, and there should not be any kind of the sharp turn. Okay, any sharp turn is not acceptable. Why? Because when we make the slope at the sharp turns, okay, we can get a vertical line. It means that the slope of the tangent line at these points is undefined. So this is not the concept of the mean value theorem or even the Rolle's theorem. So that's why it has to be differentiable. So if we look at the curve must be smooth. Or in other words, that the left hand side, the derivative of the function from the left hand side should be equal to the derivative of the function on the right hand side, which is not in case of the absolute value function. Now, if the two conditions of the mean value theorem are fulfilled, then there must be at least one point, there should be at least one point where the derivative is equals to the instantaneous rate of change, or the slope of tangent line is equals to the average rate of change, or the slope of secant line. Now when I say that the slope of tangent line and the slope of secant line are equal to each other, what do I mean by that one? Okay, now tangent line means tangent line is made, okay, when the line touches at least one point of the curve. Okay, so here in this case, let's suppose M1 is the line of is the tangent line. Okay, slope of secant line. So secant line can be made when we just join the two points of the in the curve, 2 points in the curve. Now how they are equal? They will be equal when they will be parallel to each other. So M1 is equals to M2 because M1 is parallel to M2. So how do you say? You know from from the algebra that the slope of the parallel lines are always be equal to each other. So the mean value theorem says that there exists a number C such that the derivative of the tangent and the secant line are equal to each other, or the two lines are parallel to each other. Okay, so this is the formula of the mean value theorem. F prime C equals to f of b minus f of a over b minus a. What is f of b and f of a? They are the y values at the point B and the point A. Let's try to understand the concept of mean value theorem by solving some of the questions. Find the value of C satisfying the conclusion of the mean value theorem for f of x equals to x cubed minus x squared minus x plus 1. So the first thing is in the closed interval of 0 and 2. So the first thing is that what is the name of the function? So we can say that this is the polynomial function. And whenever it is a polynomial function, okay, polynomial function, so what is the domain of the polynomial function? It's all real number, minus infinity till positive infinity. What do we mean by that? That whatever the value of the x you put in the function, you get some answer. You don't get any undefined value. That's why you can say that the function is continuous in the closed interval of 0 and 2. It's very important that you write this conclusion. Okay, now take the derivative of the function to see that if it is differentiable or not. So the derivative of x cube is 3x square minus derivative of x square is 2x minus derivative of x is 1. Now this is also a quadratic polynomial function. Domain is all real numbers, so you can say that it is differentiable in the open interval. Now these are the only two conditions of the mean value theorem. Okay, these are the only two conditions of mean value theorem. So now if these two conditions are fulfilled, then you can say that f prime of C equals to f of b minus f of a over b minus a. Okay, so when we say f prime of C, okay, so before f prime of C, only the derivative we already know. We only have to replace x by C. Now let's try to find out f of A and f of B. Okay, so I'm writing here f of a. It means what is the y value at the initial point. And here is your question. The interval is starting from 0. So f of 0. And the last point f of b, it is f of 2. So we have to find out the values of y at 0 and 2. So what do? We will replace the 0 in our original question. So we will get 0 cube minus 0 square minus 0 plus 1. If we write this in the calculator, we will get 1. Similarly, now replace the 2 in the original equation. So you will get 2 cube minus 2 square minus 2 plus 1. And check. 2 cube means 8. 8 minus 2 square means 4. 8 minus 4. 8 minus 4 is 4. 4 minus 2 is 2. 2 plus 8 minus 4 minus 2 it will be 2. 2 plus 1 is 3. So why? Yes. So they are not equal because in the Rolle's theorem they should be equal to each other. But according to mean value theorem, the slope of the line, tangent line and secant line can be anywhere, but they should be parallel. Okay, so now let's see here. Let's see f prime of c. How to write it? F prime of c. So f prime of c here. So we will write here 3c square minus 2c minus 1 equals to f of b. F of b means f of 2. So f of 2 is 3 minus f of 0 which is 1 over b. B is, look at this, this is 0 and 2. So this is a and this is b. So b is 2 minus 0. Okay, so we will write 3c square minus 2c minus 1 equals to 3 minus 1 is 2. 2 divided by 2 is 1. Bring the plus 1 over here. Because you can see there is a power 2. It means it is a quadratic equation. Now for the quadratic equation, it is important that on the right hand side you should have the 0 and the equation must be written in the form of ax square plus bx plus c equals to 0. Okay, so we will get plus 1 goes here becomes minus 1. So you will have 3c square minus 2c minus 1 gives us negative 2. Now go to the calculator and just check what factor do you get. So the a is 3, b is negative 2 and c is negative 2. So in the scientific calculator you can go to the mode 5-3 or in another calculator you go to the equation, then press the polynomial, press the degree 2 and you will get the answer. So what are the 2 points I get? I get c equals to 1.21 and the other point is c equals to negative 0.54. So look at this one. These are the 2 points. But are these my answers? No. Why? Because the value, we have to read the graph from 0 to 2. Okay. Now this negative 0.54 is here somewhere, right? Which is not where I am not reading that graph. Okay, where I am not supposed to read. And the other point is 1.21, which is somewhere in between 0 and 2. So my only answer, correct answer, which I will consider is C equals to 1.21. Now, write the C values, write both the C values while solving the question, but highlight only the correct value. Let's practice another question. So here again we have a polynomial function and we know that the domain of the polynomial function is all real numbers. So what is the first conclusion? Continuous in the closed interval 0 and 2. Second, let's try to find the derivative of the given function. So the derivative of the function is 2x. It's a linear polynomial function. So the domain is again all real numbers. It has a smooth curve. Okay, so what do we say? Uh, that the function is differentiable. Okay, so that function is differentiable in the open interval 0 and 2. Okay, so the two conditions are fulfilled. We can say that there is a point C where the slope of tangent line is equals to the slope of secant line. So I wrote the formula. So first of all, let's try to find out what is f of a and f of b to assemble each and every value in the given formula of mean value theorem. So f of a, so a is 0 and b is 2. So f of 0 find out and f of 2 find out. How? By putting these values in the original question. So 0 square plus 1 equals to 1 and 2 square plus 1 equals to 5. Okay, now here we will apply this formula. F prime c. So we have the derivative 2c. Rather than x, write 2c equals to f of b. F of b means f of 2, which is 5, minus f of a is 1 over b is 2 minus and a is here 0. So we will write here 2c equals to 5 minus 1 is 4. 4 divided by 2 gives us 2. Now here this is not the quadratic function. It's a linear function because c has power 1. So just solve it. Divide both sides by the 2. The value of the c is 1 because 2 divided by 2 gives us 1. Now have a look here. Understand, the starting point is 0. The last point is 2. So where does the 1 falls? 1 falls in between of 0 and 2. So yes, this is our C value where the secant and the tangent line slope are parallel or equal to each other. Next question. X cube plus x square. Again it is a cubic function, right? It's a polynomial function. So the polynomial function is continuous everywhere, right? So of course if it is continuous everywhere, we can say that in this small place, in this small closed interval, also it is continuous. For the second one, take the derivative of the question. So x cube, the derivative is 3x square plus x square, the derivative is 2x. Now here power 2. So quadratic function, polynomial function, which is again continuous everywhere. Okay, so and it has a smooth curve. So you can say that differentiable on open interval of -1 till 1. Okay, the two conditions are equal to each other. Now what you have to do, find it out. F of A find out and F of B find out. To put it in the formula. What is A? A is -1 and what is B? B is 1. Replace it in the question. So -1 whole cube plus 1 -1 square. So -1 whole cube gives us -1 plus -1 square gives us +1, -1 positive 1 gives us 0. You can use the calculator easily to make sure that your calculation is correct. Now f of 1, so write here 1 cube plus 1 square and you will get 1 plus 1, 2. Okay, what is the mean value theorem says? That the f prime c equals to f of b minus f of a over b minus a. Now just substitute all the values you have find it out. F prime c, so here it is the derivative. Just rather than writing x, you write here 3c square plus 2c equals to f of b. F of b is what? 2 minus f of a, that is f of negative 1, which is 0, over b. So this is a and this is b, so b is 1. Then don't forget to put this minus. We put here minus. And a is minus 1. Here minus 1. Students, they don't write this minus 1. They think that we already wrote the minus. They don't write this minus. And here is the first time where you make the mistake if you don't write the both minuses. Okay. Now 1 plus 1 gives us 2. 2 divided by 2 gives us 1. So you will get 3c square plus 2c equals to 1. Now since it is a quadratic equation, so it's important to solve a quadratic equation that the equation must be written in the form of ax square plus bx plus c equals to 0. So to make this equation equals to 0, bring the 1 over here. So you will get 3c square plus 2c plus 1 goes on the other side of the equal sign, gives you negative 1. Now go to the calculator and factor it, or you can do it manually if you want. So in the calculator we will write 3, 2 and negative 1. So we will have the two answers, 1 by 3. So c equals to 1 over 3 or 0.33, and the other is c equals to negative 1. Okay. Now both answers seems to be correct, but remember we have to study the graph, okay, within negative 1 to 1, and you are not supposed to make your lines, your tangent line at the edge, okay, at the edge of the graph. So it has to be in between, because they always say there is an existence of c point within the interval. Okay, so the answer will be c equals to 0.33. Let's see here, minus 1 here, 1 here, and 0.33 in the middle. So this is our answer. Don't take the edges. Next question. Check the hypothesis of mean value theorem. So we know that it's a polynomial function. It is continuous everywhere. So you can say continuous in closed interval -1 till 1. Second thing, you have to see that this should be differentiable, because when you take the derivative, let's take the derivative, okay? So what is the derivative of this function? F prime x. So derivative of x cube is 3x square minus derivative of x square 2x minus derivative of 2x is 2. It's also a polynomial function, continuous everywhere. You will say differentiable in open interval -1 and 1. Now that's all. Now only try to find out f of a and f of b to substitute all the values in the mean value theorem. So f of a. So a is -1, b is 1. So a is f of -1, find out, and also find out f of 1. -1. So substitute the -1 in the original question. So you will get -1 whole cube, negative, and then -1 whole square, -2 times -1. So -1 gives us -1. Here it is 1. So -1, it's +1. And -1 and -1 gives us -2. And here it will be +2. So the answer will be 0. Okay, so the second f of 1 put, so 1 cube minus 1 square minus 2 times 1. So you will get 1 minus 1 cancel, minus 2 times 1 gives us -2. Now put all these values in the mean value theorem. So what does mean value theorem says? That f prime of C equals to f of B minus f of A over B minus A. So what is f prime of C? So here is our f prime. Just rather than x, write the C value. 3c square minus 2c minus 2 equals to f of B, it is negative 2, minus f of A is our 0 over B is 1, then minus formula minus, and then A is negative 1. So negative 2 divided by 2 gives us negative 1. Okay, so I'm just writing it here. So it is negative 1. Okay, so what we will write here, 3c square minus 2c minus 2 equals to negative 1. Bring the negative 1 over here. On the other side, when negative 1 goes here, it becomes positive 1. And why we are bringing? Because we know that here the power 2 shows it's a quadratic equation. To factor the quadratic equation, it is important that on this side there should be a 0. So we will get 3c square minus 2c minus 2 plus 1 gives us negative 1. So now write in the calculator the a, b and c values. So you will have 3, then you have minus 2 and then you have minus 1. So you will get 1 and negative 1 over 3. So x equals to 1, x equals to negative 1 over 3 or negative 0.33. Now 1 is at the edge, so we will not count it as. We will check if this point is between the interval which we have to study or no. So have a look here. Go on the top here, right? This is negative 1 and here it is 1. Here it is somewhere 0, right? And what is your point? Your point is negative 0.33. This is the point. So yes, it is between the given interval. Let's try to solve one more question to clarify our concepts. So the first thing, yes, the function is polynomial. It is continuous everywhere. So you will write continuous in the given interval 2 and 4. Closed interval. Second thing, take the derivative of the function. So x cube, the derivative is 3x square minus 9x square. Multiply 2 by negative 9. So you will get negative 18. X from the power subtract 1. So negative 18x. Plus derivative of 24x is 24. And derivative of negative 18 is 0. Again, you have a quadratic function, okay, a smooth curve. So you will say yes, it is differentiable in the open interval 2 and 4. Now, if it is so, then we have to find out the value of f of A and f of B to put it in our mean value theorem, that states that the slope of the tangent line is equals to the slope of secant line. So this is the formula of mean value theorem. So first of all, find out f of A. F of A means f of 2. F of B means f of 4. From where I get these values? Here is the A and here is the B value. So put it in the formula. So 2 cube minus 9 times 2 is square plus 24 times 2 minus 18. Now better to write it in the calculator to make sure that you don't make any mistake. So 2 cube, so you will write here 2 power of 3, 2 cube minus 9 times 2 is square. Then we have plus 24 times 2, write in the calculator with me, negative 18. Okay, so we will get here the 2. Now substitute the x by 4. So it will be 4 cube minus 9, 4 is square plus 24 times 4 minus 18. Make sure that the calculations are correct. Okay, so wherever we wrote in the calculator 2, I am replacing it by the 4, and you also do the work with me so that you also understand that what is happening actually. So the answer is negative 2. Okay, so now f prime c. So here is the derivative. Just replace the x by the c and write it down. So 3c squared minus 18c plus 24 equals to f of b, that is negative 2, minus f of a, which is 2, over b, that is 4, minus a is 2. Minus 4 divided by 2 gives us negative 2. Now this negative 2, you have to bring it on the other side of the quadratic equation. Okay, to factor, it is important that on the right hand side of the quadratic equation there must be 0. So minus 2 goes here, it becomes plus 2, and you will get 3c square minus 18c plus 26 equals to 0. Now go to your calculator to factor it in the easiest way. So if go and write the a, b and c values. So a is 3, b is minus 18 and c is 26. Okay, so you will get 3.57. So the values of the c is 3.57. And another value is, let me check, another value is 2.42. 2.42. Now have a look at the number line. So initial point is 2, the ending point is 4. Now you can see 2.42 is somewhere here, right? Which is in between 2 and 4. Similarly, 3.57 is also somewhere here. So both the points fall in the given interval. So both are our answers.